So we're going to finish up this unit by learning the law of cosines. So law of sines, if you guys remember, we get to use when we have an angle side angle, an angle angle side scenario. When we do our law of cosines, we're going to have side angle side and side side side. So this means you're given two sides and the included angle, which is different because if it wasn't the included angle, we have to use law of sines. When we say side, 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 it means you know all three sides of the triangle. So the cosine, the law of cosine says a squared equals b squared plus c squared minus 2bc cosine of angle A. All right, now we could also change around what we're given and say b squared equals, and if I have b squared here, I'm going to have an a squared plus a c squared here minus 2ac cosine of b. And I could also do this as a c squared equals a squared plus b squared minus 2ab cosine c. All right, so kind of confusing looking, but if you kind of pick up the big idea here, it looks almost like Pythagorean theorem. So you've got a squared and then you've got the other two sides squared minus, and you'd say 2 times the BC cosine A. So you'll get used to it. All right, so if we go ahead and we draw in our triangle for this example, we have triangle A, BC. All right, and when I label my sides, side C is 11, angle A is 42, and side B is 13. So up here when I was talking about included angle, this is the scenario we have here, side, angle, side. So that tells me it's law of cosines. Also, if you tried law of sines, you would notice you could say sine of 42 over A would be sine of B over 13. There's no way to get an equation that doesn't have two unknowns. So if you aren't sure, there's only going to be one option that works. So if I go ahead and I set this up, I'm going to find side A by saying a squared equals b squared plus c squared minus 2ab cosine of 42. So this whole line is just a number I get to plug in my calculator. So if I go ahead and I look here, I'm going to plug this in, and we'll say 11 squared plus 13 squared minus 2, and then we would say 11 times 13 cosine, and I'm just going to do a quick check. Yep, I'm still in degree mode. Cosine of 42. And when I hit enter on this, that's going to give me the value of a squared. So just don't forget we need to take a square root of that number, and we get an 8.8. So A is 8.8. All right. Now, once I know A is 8.8, then we have to find B, angle B, and angle C. So if I want to do that, then you could switch back to law of sines, but you just have to be careful that if you're going to do law of sines, that you find the smaller angle first, all right, just in case in the off chance that the bigger angle is obtuse. Your law of sines is going to mess you up because of the rule with the idea of two triangles possibly existing. So I actually prefer to just, once it's a law of cosines problem, to do law of cosines again. So if I go ahead and I do that, then I would actually have that if I wanted to find B, I could say a 13 squared equals an 11 squared plus 8.8 squared minus 2 times 8.8 times 11, and then cosine of B. All right, now when I go ahead and I think about solving this, the one thing you have to be careful with, you can't group all of this together. All right, so I can subtract an 11 squared over, I can subtract an 8.8 squared over, but this is stuck to the cosine B. All right. So when I go to plug this in my calculator, I'm going to first do, all right, A, and I'm just going to drop that over here. I'm going to first do 13 squared minus 11 squared minus 8.8 squared. And I'm going to hit enter there. And then I actually have to divide this, and I'm going to put parentheses by a negative 2 times 8.8 times 11. And so that's what our inverse cosine, and I'm going to write some of this stuff out. I'm just putting all the operations in my calculator right now. So this is where we get to in this problem, that we have, I subtracted the 13 squared with the 11 squared and 8.8 squared, and I got a negative 29.44 equals this quantity. So then I divided by, and that's the point, the negative 2 times 8.8 times 11, which is then where I got the 0.152 equals cos B, which is why then I had to use inverse cosine. So I use inverse cosine, and that is how we would find that this angle is an 81. Once you know that angle, go ahead and just subtract from 180 and you can find angle C. All right, so if we go ahead just in our calculator again, 180 minus 42 minus 81, and 57 would be angle C. All right, now one thing that turns into an issue when you guys are answering your questions, notice here when it says solve the triangle, we are filling in every part of the triangle. So this is kind of my final answer here. I can see all the sides with all the angles filled in. That's how we are finishing up these problems. So just make sure that you are finding all of the unknown stuff in each of these questions. All right, so let's look at another example. So over here, find the remaining sides if we have the following information for triangle PQR. So we'll go ahead and draw the triangle. If you try to do these without drawing your triangle out, you're going to drive yourself crazy. So please, please, please just draw the triangle. So we know P is a 4.8. I know Q is a 6.3. And I know R is a 32. All right, so go ahead and try out this problem. I'm gonna ask that you pause it, give it a shot, and then I'm gonna show you what numbers you should have gotten. And so I just want you guys to make sure you get the exact same triangle filled in. All right, so if you guys just go ahead and double check these answers, here we would have the angle Q, oops, hold on, I started to write it out for you, 3.3 times 4.8 cosine of Q. So you'll see here, angle Q would be a 100.5. Now, if you were wondering what I was talking about when I said once you start with the law of cosines, you should do the angles with law of cosines also. If you did law of sines for this problem, you would not get a 100.5. You would get the acute angle. So that is why, and if you want to try it to see, you can see that it gives you the wrong answer. So you're better off just sticking with the law of cosines once you start with it. And you just have to do it 2 times. So it's not that bad because now you know 132. So that's going to leave a 40. And then since we have the 0.5, we would say a 47.5 here. All right. So the law of sines will mess you up. It's the easier one to use. But with law of cosines, once you start law of cosines, you have to finish with law of cosines. All right. Now, some people prefer to just go ahead and find the acute angle, and then you don't have to worry about it. But it's easier. Let's just use law of cosines. All right. So just quick summary. these are our 3 cases for law of sines, and these are our 2 cases for law of cosines. Now, remember the only time you have to worry about checking for a second triangle is this case. All right, so the ambiguous case, which is side-side angle, you could have 0, 1, or 2 triangles, and that's what I talked about in the last video. All right, so if we are using the law of cosines with a side, 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 all right, go ahead and find the largest angle first, and then you can really do whatever you want in the problem. So I'm going to go ahead and do an example of that. I'll leave this one for you guys to do. All right, but let's go ahead and just do one of these where it's side, side, side. So in number 5, all right, I'm going to draw the picture out up here. All right, I have A, B, C, where side A is 28, side B is 35, and side C is 20. So to find the biggest angle first, it means I need to find B. All right, AC is the longest side, so angle B has to be the largest angle. So if I go ahead and I set this up, it would be 35 squared equals 20 squared plus 28 squared minus 2 times 20 times 28 cosine of B. All right, so go ahead and do that solving, and we're going to get our cosine, we're going to get whatever B is going to equal. All right, so if I arrow down here, we would say a 35 squared minus 20 squared minus 28 squared. And then we're going to divide by the negative 2 times 20 times 28. And then we're going to use inverse cosine. And we get a 92. So again, if you had done this in the wrong order and then you tried to use your law of sines, you are going to get the wrong answer. So law of cosines is the way you get an obtuse angle. So angle B is now 92. Now here's the great thing. Once you have your obtuse angle, a triangle can only have one obtuse angle. So now you can use law of sines to finish the problem up. It's just until you know whether or not there's an obtuse angle, you can't use it. So once I know that this is 92, I can go ahead and say sine of A over 28 equals sine of 92 over 35. And that's how you're going to find your A, and then do the exact same thing to find the C. So I'm going to go ahead and write down what angle A and angle C are. You guys can write out your steps and make sure you can solve them on your own. But that's your law of cosines, which is the last thing that's going to be covered on our unit test. All right, so I got A was 53 degrees and C was 35 degrees. So I do want you guys to try these problems just for extra practice, and I will post the answers on Canvas so you can check.